It's another wonderful day to learn geometry. Today we're going to be wrestling with triangle congruence being proven using the angle-side-angle postulate and the angle-angle-side theorem. We are in our fourth unit on covering congruent triangles, how to show that triangles are congruent. We learned in the previous video about applying the side-side-side postulate and the side-angle-side postulate. And so these are a couple other shortcuts that we may get to apply in this unit. Our goals today are to prove that triangles are congruent using either the angle-side-angle postulate or the angle-angle-side theorem. The difference there again is that the angle-side-angle postulate is something that we are going to accept and believe that it's true. The theorem is a shortcut that we actually could prove, and the proof of that would include applying the third angles theorem to make it look like it's an angle-side-angle postulate, all right? And so the goal there is we're not actually going to do that theorem, we're not going to prove that theorem, but we are just going to apply angle-angle-side as another triangle congruence shortcut. So here let's talk about the angle-side-angle postulate. First, we want to make sure that we understand what it is and what it is not saying. So when we say angle-side-angle, again, the name of the postulate, ASA, is to show you that the side is included between the two angles. That's the order in which the letters are written tell us what the shortcut is that we are going to be using. So if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. Understanding how that works in proving triangles congruent is going to require that we are paying attention to what we see in the figures that we are provided with. So here is an example where we have three triangles. All right, we've got triangle dog, triangle ABC, triangle XYZ, and the question is, which two triangles are congruent using the angle-side-angle postulate, and let's provide evidence. What we should note is that we have congruent angles in all three triangles. We've got a pair of congruent angles in all three triangles, and we've got a pair of congruent sides between all three triangles, all right? And so the goal here is to say which pair of triangles is actually congruent using this angle-side-angle secret shortcut, all right? The angle-side-angle postulate. Well, what we should note is that this angle that's marked twice corresponds to this angle that's marked twice. This angle that's marked once corresponds to this angle that's marked once. So D is congruent to A, O is congruent to B. But the segment in between these angles is not marked. All right? So I cannot say that triangle DOG is congruent to triangle ABC. That is not going to be true. Rather, what I should note is that triangle XYZ is congruent to triangle DOG. I'm going to write that out. Triangle DOG is congruent to triangle XYZ. And the reason is angle-side-angle, because we have a pair of angles congruent, another pair of angles congruent, and then the side that is in between those two pairs of angles are congruent. So XY is congruent to DO. Angle X congruent to angle D, angle O congruent to angle Y, segment DO congruent to segment XY. Let's take a look at this situation. Here we have, it looks like two triangles, and we are told some special information about the sides and angles in this figure. First of all, we are told that the angles at E and D are congruent. We are told that segment AE is congruent to segment BD, and we are also told that segment AE is parallel to segment BD. So if I'm going to complete this proof to prove that those triangles are congruent, and if I want to use angle-side-angle in this case, I've got a pair of angles, I've got a pair of sides, I need to show that I've got a pair of angles here, at angle A and at this point B. I can't call it angle B because there's all these different angles at B, so we need to be careful here. But I want to show, I don't know this information in red, I want to show that these angles are indeed congruent to each other. Can you discern why those angles are congruent to each other? Think on that for 5, 4, 3. These angles here are corresponding angles, all right? We've got this side is parallel to this side, and here is the transversal. When we look at this picture, we can tell that these are corresponding angles, and if these lines are parallel, then the corresponding angles are congruent, okay? So the reason why the angle at A is congruent to the angle at B, which I have to name properly, it is because they are corresponding angles. So let us write this out as a two-column proof. I will try my best to model that for you. The first thing that I'm going to say is that segment AE is parallel to segment BD because they told us it was, or they told us they were parallel, which means that the angle at A is going to be congruent to the angle at B. By the corresponding angles postulate. We are also told that the segment AE is congruent to the segment BD. And finally, we are told that the angle at E is congruent to the angle at D. We don't have to have these in this exact order, but step 2 has to come after step 1. I cannot make this statement unless I make that statement. The reason why I put them in this order is so that we can show that we have a pair of angles, a pair of sides, a pair of angles, and that the pair of sides is included between the pair of angles. And since we are going to use the angle-side-angle postulate, I wanted to structure my proof in that way. All right? If we think ahead before we just start writing all the given information, we can come up with the plan for our proof, think about how we're going to write it, organize our steps in such a way that they make sense and they bring us to that logical conclusion that the triangle AEB is congruent to the triangle BDC. Again, by the angle-side-angle postulate. The angle-angle-side theorem says that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. There's a lot of information to process there. First of all, having two angles congruent to each other is good stuff because we learned in section 4.2, I believe it was, that the third angles then are congruent, all right? If two pairs of angles in two triangles are congruent, then the third pair of angles is also congruent. We call that the third angles theorem. That was theorem 4-1. And so what we're finding here is that if we have two angles and a non-included side, as long as it's the corresponding non-included side, then those triangles are congruent because we could apply that third angles theorem to say that now we have all three pairs of angles congruent, and then we've made an angle-side-angle postulate situation. What this does using the theorem is it cuts out those steps of applying the third angles theorem and then saying that we're using angle-side-angle. Instead, we can skip that and just say, hey, we've got angle-angle-side. All right? And so let me explain that maybe a little bit more clearly. If I've got these two triangles, and I've got a pair of angles, and then I've got the corresponding non-included side. This is important right here. Angle, angle, and then the next side that comes in that order. This is angle 1, angle 2, and then this is the side. It is not going to work if we have a corresponding non-included side. I'm sorry, a non-corresponding non-included side. So you see how this is angle 1, angle 2, and then the following side? This is not the next side. So these sides are congruent, but the order of the letters isn't going to match. It's not going to line up. All right? So this is the situation where we do have angle, angle, side. This does not work. So let's apply that angle, angle, side theorem in this situation. Now my proof is going to be a little bit silly here because we can do this a couple different ways. But I'm just going to try to stick with the angle, side, angle approach. Given that segment RP bisects angle SRQ, and given that angle S is congruent to angle Q. We can structure this in a couple different ways, but what I want to do is I want to use angle, angle, side. So we know that this angle at S is congruent to this angle at Q. We know that this segment bisects this big angle. We had this big angle SRQ, and it was bisected, which means that this angle is congruent to that angle. All right, angle SRP and angle QRP are now congruent. We need to have a corresponding non-included side, which means that either I need angle, angle, side, or I need angle, angle, side. All right? So there is nothing in this picture that leads me to believe that SP is congruent to QP, but I can say that RP is congruent to itself, again, by the reflexive property of congruence. So what we're going to do is we're going to structure this by saying this pair of angles is congruent. I then want to say that these angles are congruent, but I have to restate this given information so that I can say that these angles are congruent by the definition of bisect. And then I will say that RP is congruent to itself. So step one, angle S is congruent to angle Q because it's given information. Then segment RP bisects angle SRQ because it's given. But this means something. This tells me step three. This tells me that the angle SRP is congruent to the angle QRP. And that is by the definition of bisect. Because that angle is bisected, it is cut into two congruent parts. And finally, step four, segment RP is congruent to itself by the reflexive POC. Therefore, our triangles are congruent. I know that it's angle, angle, side because I had a pair of angles, and then a pair of sides. All right? I planned the proof out that way. Just because you make your statements in angle, angle, side order doesn't mean it's angle, angle, side, but we specifically structured our proof because we knew that was the direction that we were headed in this proof. Example 4. So again, we're still practicing writing proofs. We want to get good at this. We want to get better at it. You're going to notice that there's a lot of repetition, all right? And when we are doing these proofs, we are paying close attention to either using side, 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 angle, side, angle, or angle, angle, side. This proof we could do as either an angle, angle, side, or an angle, side, angle. And so depending on that, we may have two different proofs here. That's why step 5 is blank. And so we will work through this in a couple different ways and try to make sure that we cover all the bases. So the first thing that I want to mention is in this picture we have XQ is parallel to TR. So I have that little triangle I would draw on the line segments to say, hey, these lines are parallel to each other. The other thing, it says that XR bisects QT. So here's what that means. If this segment here bisects this segment, it means that this segment got cut in half. All right? So what I want to do with this information is I want to show that we have a pair of congruent triangles. What you'll notice is that I only have one pair of sides congruent, but I don't have any angles listed congruent. And this is where we need to think about how we're going to do this proof. So here are some statements. We're missing one. And we want to come up with the reasons for each of those statements, including the missing statement. So that missing statement, that third or that second angle that we're going to find here, is going to depend on what we visualize when we see this situation. All right? And there could be two statements that we could make, but there's also two different reasons that we could provide for one of those statements. Okay, so it's a little bit silly. But what we should notice is that the angles at Q and T are marked congruent after we stated that these lines are parallel. So XQ is parallel to TR, then they say that these angles are congruent. Well, these angles, if you look at them, you should notice that the angle at Q and T are true because of the alternate interior angles theorem. Then we recite that given piece of information that XR bisects QT, that again is given information up here, which means by the definition of bisect that we've cut that segment in half. We need another pair of angles, all right? So this depends. Do you want to say that these angles are congruent? Or do you want to say that these angles are congruent? All right? Most folks would look at this and would have noticed immediately, hey, you've got a pair of vertical angles there. Why didn't you even mention those first, Mr. Hibbett? All right, that's a great observation. Because you have choice here, all right? You can either say that angle X and angle R are congruent. Again, that's alternate interior angles theorem. We could have used that up here with step 2 and it kind of made that statement at the same time. Or we could have used the vertical angles theorem, all right? And then said these triangles are congruent by angle, side, angle. So it's either angle, angle, side using angles X and R congruent, or it's angle, side, angle using the angles around M. I'm going to use the angles around M for 2 reasons. One, I want to make sure that you remember to apply the vertical angles theorem. And then 2, I want to make sure that you know how to name angles using 3 letters, because I can't just say angle M is congruent to angle M. I've got to use all 3 letters there. So I'm going to say angle XMQ is congruent to angle RMT. And the reason there is the vertical angles theorem. And then these triangles are going to be congruent, in this case, by angle, side, angle. Pair of angles, another pair of angles, the included side between those pairs of congruent angles, or angle, side, angle. When you're tracing it, you say, I've got an angle, I've got a side, I've got angles. You can see that it's angle, side, angle. All right. As I said, though, in the video, or as I said in the video that we were watching right now, as I said moments ago, you could have said that angle X and angle R are congruent by the alternate interior angles theorem. And then your reason would be angle, angle, corresponding non-included side. So it would be AAS instead of ASA. All right, that takes us to the end of our lesson. My goal is that you are now able to prove that triangles are congruent using both of these shortcuts, the angle, side, angle postulate or the angle, angle, side theorem.